And we on Stage Bob here move on to our next presentation, which the speaker is Mohammed Sadek Ebrahimi. He got a PhD from Heidelberg University and the GSI. GSI is the Heavy Iron Research Association in Germany. For those not familiar with it, it's the institution which created and named a lot of the elements in our periodic table. Since 2019, he's employed at Endress+Hauser, where he works as an advanced sensor engineer. And in his talk, he's going to talk about the current state of the industry of industrial sensing, about the limitations and challenges in this field. So, Sadek, welcome to our stage. It's great to have you with us, and I'm looking forward to your presentation.
So, hi everyone. I hope you hear me and you have my presentation on your screens. Thank you very much, Roman, and thank you very much, Bitcoin, for inviting me. I would actually speak about an industry that is often in the background doing a lot of job and giving us the possibility, enabling and facilitating many other industries to provide what they are doing and go on forward. And in this industry, there's a great tie to quantum technologies, which I will try to illustrate how these two can come together and how they can mutually benefit from each other. Because not only industrial process engineering or sensing can benefit from quantum technology, but I would say quantum sensing and quantum technology can also mutually benefit from what we have to offer from industrial process engineering. So I would first of all tell you what quantum process engineering means for just a few short sentences. Every morning when you wake up and you take a glass of water, either from your tap or from a bottle of water and drink it, you automatically engage with industrial process engineering in the sense of sensing, regulations, and electronics that sits behind it. The story goes on with chemical industry, food and beverages, life sciences, and on to many others, such as you all are engaged and know about the mRNA vaccinations nowadays. That is only possible to produce in such a mass number because one of the key components is the sensors that companies that are involved in industrial process engineering are offering. What does that mean in general? When you walk into a plant of production in any of the named industries, you will see devices such as the ones on your right side of the screen. And they are there to measure the flow of a component in the process, the level that is of the material in the tank, the pressure, the analytics, how much CO2 or oxygen is in the process, the temperature, and mainly nowadays it is very important to have a strong data handling and digital communication services also included in this system. So you already see some key words that can or are oftenly mentioned in quantum sensing or in sensing in general or in quantum internet or quantum communication stuff. So, but I have to also mention this work of the industrial automation or industrial process engineering does not finish on the plant. And more often than not, a technician, a scientist, or engineer must take a sample, run back to the lab, make some tests, and with the result of the test, go back to the process and do an automation, do an optimization. Let me just one slide tell you who we are at Endress+Hauser. We are a family company since 1953, and we are 14,500 people trying to enable our users to do the measurements that I mentioned with the knowledge of their process as much as they give us, that they provide us, to provide the best solutions for the easiest process automation. In this slide, I would try to show you why industrial sensing and automation is a very key component for the second quantum revolution. As you can see, and this is an example from our company, and this situation is similar in the industry. Why is it so? Because we have to provide our customers the state-of-art measurement technique that passes with their processes. So here you see, since 1962, we have a so-called radiometry level measurement, which in turn is a first quantum sensing generation, first generation of quantum sensing technology, and many other technologies, as you can see here. And I will not go through all of them by detail. Rather, I will show you this slide that tells you what we have done and what we have in portfolio as an industry. Yeah, this is an example again by Endress+Hauser, but it's pretty much all over the industry the same. So we have classical measurement principles in our toolboxes. And nevertheless, for many challenging environments, we have seen that more than that is required. So pretty much quite early, we adopted first quantum revolution. And in the course of time, we adopted MEMS technology. And then nowadays, I can say we have also maximized the benefits that one can expect from the first generation of quantum devices, such as spectroscopy, let it be Raman spectroscopy or IR spectroscopy or whatever in this sense. And communication, digitalization, and advanced material are stuff that are flowing in. But nevertheless, companies like us, in the beginning of the century, started establishing new bases of technologies that are more up-to-date and are more advanced, or acquiring companies that do more in the sense of in the field of sensing based on more advanced technologies. The question is, why go down this road? Why go through all these efforts? And the answer is rather straightforward. Modern industrial processes need modern instrumentation. By the development that we are seeing step by step nowadays, we know that our environments are getting harsher. That means we can have higher temperatures or lower temperatures, higher pressures, lower pressures, more aggressive environments. And then we need improved accuracy, because we need to have even more control than before on our processes to achieve highly complicated products. We now know, as I've told you, we spend a great amount of time going back and forward between the lab and the plants every day. So it needs to come to a media and chemical analysis that we reduce this time. As you all know, on your phones, you can basically have applications that in background, there are algorithms that give you more understanding of what you want rather than a direct measurement. So for example, your app can tell you what is your BMI on your daily scale or such a thing. So that means also we need to provide the customers the same level of comfort by introducing such a qualities. And these qualities will be known as quality parameters. Advanced digitalization is a keyword, and AI. And we want as many as sensors in a smaller packet. So all in all, the industry goes in the direction to give the users more comfort and convenience and introduce a higher level of resilience and accuracy in the sensing systems. Let me give you two examples of what we do. So we recently introduced the device. It's a radar for measuring the level, and it's fully integrated with IoT in the industrial Internet of Things, which goes through a cloud and lets you, from your comfort of your couch in the home or in your office, to measure what you want to measure. Or in a sense of quantum, in a sense of quality parameters, recently we have introduced, or we are working on a product known as the fermentation monitor, which gathers information from many sensors and boils it down to one parameter: is your beer ready or not? So with all of this said, I now make a transition. Why quantum sensing? Classical measurements and principles and connectivity reached us to a very high point and a high level. Now with digitalization and also with artificial intelligence and creative mix and match of the classical parameters, we are achieving, or we are on the rise of very new levels already. Now, consider more digitalization, artificial intelligence, and new measurement principles mixed together. What do I mean by new measurement principle? The first and the most interesting one is quantum technology from the second revolution and quantum sensing. Why is it so important? Why does it sound so good for industrial automation? Because they are atomic scale measurements, which has benefits for us, such as being able to do measurements that are entangled with fundamental constant. They are rock solid, like diamonds, and they have the high potential for a new mass market. If we are to bring the second quantum revolution to a good point, we need more and more mass markets. As I told you, diamonds are very interesting, and we think that diamonds have a very good potential for this industry, because with a diamond, a quantum system, you can do various types of measurements, from magnetometry, electric field measurement, temperature, RF measurement, direct pressure measurement, pH measurement, and all with the material that has an enormous and unbelievable temperature stability and mechanical stability, and is process stable, and it's biocompatible. So we internally at Endress+Hauser normally say diamonds are a sensor's designer's best friend, not as a classical one. So how does a diamond work? I'll tell you just a few words. So if you have your diamond with the carbon atoms around it, and if you implement, instead of a carbon atom, a nitrogen, you will end up with a vacancy. If you excite the atomic layers with a green light excitation, in return, you get a red fluorescence. And then if you introduce a microwave signal to the mix, the system gets sensitive to your magnetic field in the form of deep that you see, first of all, by introducing the microwave and generating a so-called dark state. And then when the magnetic field comes in, this dark state goes hand in hand with the deep generated by the microwave, and based on the amount of the magnetic field, you get a separation between the two dips. So I told you we at industrial automation community, industry, and Endress+Hauser have a deep knowledge of what our customers require for sensing and automation. And please, again, keep in mind, when I say customers or users, I basically and virtually mean any industrial company that you can think of. And then we see a new system that has many capabilities to realize the sensor of future that I introduced you. So we basically are working towards such a sensor, which hopefully will get us the next milestone that we want. And it should be sooner than later, much sooner than a quantum computer, hopefully. In doing so, we also believe that the collaboration with university, other industrial companies, and also the government is a crucial part of this revolution. Therefore, we joined the so-called QSens cluster for future, which is centered in around the Stuttgart University. And together with the University of Stuttgart, we formulated a sub-project called QIND, which is basically quantum industrial measurement technologies. And in this, we will try to achieve two specific sensors, and which I think, due to the scale of this and the time of this presentation, I would skip over that. So all in all, I would tell you the future of quantum technology and industrial process engineering is entangled. How so? Quantum sensing is offering access to new and challenging processes that we normally cannot get it from classical ones, or what is also contemporary systems, and they are rising, they exist, or they are rising. Chemical and media measurements have never been more in our grasp than nowadays with the quantum sensing. And more on-site measurements instead of lab is now possible due to the compactness, due to the smallness of uncomplicated situation that quantum sensing will offer us. Our community, on the other hand, can provide professional mass production market and gives a periphery of currently available technologies. Know-how required to drive the second revolution. And all in all, I personally believe that quantum sensing is an exit strategy from any foreseeable quantum winter. And because to reach a quantum sensor that is mass market, they already exist in some forms in the market, as you already know. But nevertheless, grasping the potential of the industrial process in engineering and implementing it in this community can provide us the possibility, an exit strategy from any quantum winters that can happen. And with that, I would like to thank you very much for your attention. And I would say we are all riding a quantum express train, and I do believe that one of the next stops would be industrial process engineering, because the market exists, the idea exists, the need exists, and the technology seems to be in an acceptable level. It should be adapted. There's no doubt about it. There's a lot of work to be done, but it's in a good, in an acceptable level and situation. Thank you very much.
Well, thank you. And I think the sentence, "Diamonds are sensor designers' best friend," will definitely stick with me long beyond this talk. So thank you also for that. One question that comes to mind to me is, so I understand that with quantum sensing, in a lot of different fields of sensing, a lot of different types of sensors can be potentially significantly improved. But can you try to outline a bit which fields, which types of sensors would profit the most or will potentially have the biggest increased potential from quantum sensing, and which maybe will not profit so much from this?
That's a very good question, and I would answer it in the following manner. It's not about which one will profit more, but it's more about which one will profit first. Yeah?
Okay.
Because as you know, the sensing industry in this scale is always looking for different types of measurement. And if you look into a portfolio from a sensing and automation company, you will see all different kinds of principles. And based on the readiness, you will get a product in time. So I would say it's not a question of which one, but rather which one first. Yeah? And I do believe that our community has already, the scientific community, especially in Germany, has a good few candidates. And for example, there are sensors being developed in Stuttgart for as gyroscopes or such. And I do deeply believe that they are going to be the first ones that are reaching the mass market. In our industry, also the need or the priority is rather to so to say is clear, and it's a broad range. I would not prefer one over another.
Okay, thank you so much. Thank you again for being with us, for giving your talk here. You will be available, just like the other speakers before, for the next 15 minutes in the speaker's corner. So to the audience, you're invited to meet the speaker, to meet Sadek in the speaker's corner. Please feel free to do that in the next 15 minutes. Thanks again to you, and goodbye.